Okay, as I mentioned to you before, hypothesis testing is the inferential statistic. Okay, hypothesis testing. So to understand hypothesis testing, first of all, you need to understand what is the hypothesis. What is the hypothesis? Yes, hypothesis can be defined as the preliminary assumptions or your predicted assumptions based on a certain condition. So to understand the hypothesis, you must understand what is the inference. To understand the inference, you need to go back to your school teacher lah. So the inference is actually the preliminary understandings of the situation, perceptions about what will going to be happen in your experiment or your data that you need to be analyzed. Okay, that's we call under the hypothesis or inferential statistic. Okay, in the hypothesis testing, they have 5 steps that you need to remember. Hypothesis testing consists of 5 steps. Okay, so in the hypothesis testing, the 5 steps will be as it is until you study and continue into the higher level. Even you want to do master, PhD or whatsoever, you're still using the same thing that I'm going to share with you after this. The first one in the hypothesis testing that I need you to always remember. Why I say always remember? If we are going to do hypothesis testing, I would like to ask you to write down these 5 steps in any exercises that we are going to do after this. So you need to take out a piece of magic paper. I call it magic paper lah. We call it a piece of paper, and then you write on your hypothesis testing step by step. Unless you are so terror like me, you don't need to write. If you feel you're not terror, you write. If you don't write, you are so terrorful. Is there any terrorful word? No terrorful word. Okay, the first one. The first one in the hypothesis testing, you must have the preliminary assumptions of the origin or the original assumption. We call it as the null hypothesis. You know about the null hypothesis? Have you heard about the null hypothesis before? Null hypothesis. N-U-L-L hypothesis. Did you know about the null hypothesis? Null hypothesis indicate the assumptions of origin. Assumption for origin in this case are talking to you about the situation or the conditional where if you do not run this thing, what will happen? In the original one, what it is. For example, kan, I got a car. I got a car named as BMX and another car is BMY, for example lah. So I want to make a comparison based on the acceleration, kelajuan, speed. So how I'm going to do this study, I need to have the preliminary assumption based on the speed. So what is the example of the preliminary assumption? The car should have the similar speed, correct or not? The speed of the car is the same because that is the preliminary assumption, assumptions of origin. I take another example, a very simple example. We have the weight. You know weight? Weight is berat, right? Berat between male and female. So what is my preliminary assumption? Weight of female are same like weight of male. That is the preliminary assumption. Kita panggil sebagai you punya asal lah, pandangan yang asal ataupun assumptions of origin. Yang mula-mula sekali you perceive if you not doing anything on your sample. Itu dipanggil sebagai null hypothesis. Contoh lain, if you can remember my example before, I'm talking about the IQ, right? I want to see whether you all are more than 120 or less than 120. So this one is my null. Null means that is my standard. I want you having a score of IQ more than 120. Then I'm going to use the hypothesis testing to see whether you are more than or less than. Understand or not? So what is my null? My null is this one lah. I got a standard. So this one I don't get a standard, but I got an assumption. What is my assumption? I want to test a speed. Therefore, I need to have the preliminary assumption. My preliminary assumption will be the speed is the same, something like that. Understand? Okay, we are going into the context of the different one. Let's say you have A and B. This one is the drug. You know drug? Drug is what? Drug is poison. Drug is your medicine lah kan, medication that you want to give to your patients. So for example, we have a drug A and drug B. So we are going to give and administer to our patients. So what is our preliminary assumption? Let's say the effect is we want to measure their blood pressure. Let's say lah the effect we want to use the blood pressure. So what is your preliminary assumption? The blood pressure will be the same. Very good. Will be the same lah between A group and B group, because the A group will receive the A medication. The B group are going to receive the B medication. And then after we administered those medication, and then we look for the comparison whether there is a significant difference or no significant difference between the pre and post and between the groups. So that one we call it as the hypothesis testing. The first rule of thumb, state your null hypothesis. That is 1A. Understand or not? The next one is state your hypothesis alternative, HA, or we call it as a research hypothesis. You can call it as the alternative hypothesis, or you can call it as the research hypothesis. Research hypothesis or alternate hypothesis is actually your research objective or your main idea that you want to highlight. In my case, for example, this speed, actually I want to say that my car are better than other car. You see? Because that is the purpose of doing this experiment. So therefore, I need to have the feeling, okay, I will say that the similar speed at the beginning. And then I'm going to test both of the cars. And then I'm looking back into the speed. Which one is different to which one? So I hope, or I may perceive that I want to look into the difference. If there is difference, that's mean my car probably higher speed than those who are becoming my control car. Understand or not? So that is the hypothesis testing. Why we do like this, so rigid and so difficult to understand? Because of one reason, scientific. Because we want to make it scientific. For example, if I want to say that this watch are very good, it's very unethical for a scientist to say that this watch is good. But it's ethical for the research scientist to say that this watch is not good. So that means what? It's good. But that is the way the science or the nature of we want to prove something. If you want to say that this thing is good, we are going to say that these things are not good. So that means it's good. That's how we want to make a research. Other than that, it's not research, it's a testimony. Oh, I already drink this thing and look at me, I'm slim. That is testimony, not research. That you can find out in the Facebook, in the any testimony given for you. Correct or not? Because there are no hypotheses in the first place. Okay, so let us go into the next one. Same also goes to this one, A and B. So A and B, drug A and drug B. So we have a perceptions of the null hypothesis. The blood pressure will be the same between the group. And then after we administered those drugs, we want to see the difference. So this is what being occurred in your workplace or in your healthcare setting. There are some scientists running their experiments towards the patients to look into the effectiveness, into the safety of the medications that they want to provide for the patient. Okay, the alternative hypothesis or alternative or research hypothesis can be divided into two different hypotheses. The first one we call it as a non-directional hypothesis. Non-directional means that no direction, no arah, tidak ada arah. For example, I would say that the A and B group have similar blood pressure. This is pre. Pre means that before we administered the drug. After I administered the drug, I would say that the A and B do not have the same blood pressure. What I mean by do not have the same mean if the data is normal. Correct or not? Because that is what we want to measure in the first place. So this one we call it as a non-directional hypothesis. Non-directional do not have any direction towards the statement. The next one we call it as a directional hypothesis. Directional hypothesis is what? They got direction. For example, I want to say that the A have more blood pressure or higher blood pressure or more effective rather than the B. So when you see this sign, that means they got direction. Same also goes to my testing car. I got this car, right? So I want to say that my car are better than the other car. My alternative hypothesis will indicate as follows. BMX more than BMY. Understand or not understand? So the research hypothesis or alternative hypothesis are fully depend on you, up to you, because this is a research hypothesis. It depends on your research. Unfortunately, and usually I may advise students to choose the simplest one. The simplest one, of course, lah, non-directional hypothesis. Okay, non-directional. You will say that the weight of the male and female in my samples are similar. That one is what? Null. So my alternative hypothesis will be the weight of the male and the weight of the female will be not the same or will be not similar. That one we call it as the alternative hypothesis with no direction indicated. Okay, tak ada direction dengan ada direction. Faham tak faham ni? There are some sleepiness occur in my class. It's okay. You already stuff mean that stack inputted a lot of information. Some of you cannot digest it very well, so therefore you will have some dizziness and end up with sleepiness. It's okay, normal when you learn about statistics. Okay, never mind, ladies and gentlemen. That is the first step. State your null and alternative hypotheses. Okay. Finish or not finish? Finish already. Usually, the people who are sleepy inside the class are the clever one. Usually lah, for information. Macam saya tak boleh tidur senang-senang because I'm not the person who can easily fall in sleep. Fall in love easily. Fall in sleep cannot. Okay. That is just example. Okay, the first one is state your null and alternative hypothesis. The next one, you must state or choose your alpha. What we meant by alpha is your rejection region or your critical point. This is the second step of our hypothesis testing. Okay, to understand this one, I may want to use following examples. Usually in health science or in epidemiological study, in the settings of the human study, in the health setting, not the clinical setting, because the clinical setting might want to reduce the error. So probably you are going to use 0.05 as your indicator. So your alpha will be set at 0.05 level of significance. So that's mean anything that beyond this value, this critical value, you will make some decision based on the step number 4. Never mind, I will explain to you after this. Okay, this is the second step. State your null. State your alpha. So your alpha usually 0.05, but you can increase the precision, the accuracy of your research by decreasing the value. For example, my alpha is equal to 0.01. What does that mean? This is more precise rather than this one. Okay, I want to make one example. Did you hear something like, okay, this product can kill 99.99% germs? Did you heard about that kind of advertisement? So what does that mean? 99.99% of the, yes, that means their alpha is equal to 0.001. This is more precise. Possible? Possible lah, because that one are being considered and being tested inside the laboratory setting. But if you tested outside the lab, we might want to consider some errors. You know, this one are talking about the accuracy. Therefore, they will not say 100% germs will be killed if you use this thing. That is very impossible. You must still have some error. The difference is how big is your error, whether your error is too big or so small. So don't get being cheated by those who are trying to advertising. This thing is very good, 100% cure. What the fish? No. There's nothing to do with that. Okay. So the alpha, can you understand now? The alpha. So the alpha that being set by that company, for example, they set 0.001. So they need to prove that their alpha is actually at 0.01. Therefore, they say that 99.9%. So actually they are looking into the rejection region, you know, rejection region, the way that you want to reject the null hypothesis in the step number 4. Okay, now we are going into the step number 3. The step number 3 consists of 2 different approaches. The first one we call it run the statistic. Itu je. Run the statistics means that you run the statistic using the software and you report. The keyword here is run and report. What you need to report? You need to report the p-value. The p-value or the significant level or the critical level. And then you need to report another one will be the statistical value. That is the first approach, statistical value. Unfortunately, for none of you, for my students, in terms of the epidemiological student, they can run the analysis, but they also need to calculate. They need to calculate using a manual calculation. For example, this is just for example, they want to know the Z distributions of the data, so they need to estimate the Z. First is equal to x minus the mu divided by the sigma, and then they need to do the run hypothesis. Z is equal to x minus the sigma divided by the sigma over the n, the power of 2. So this one is about the hypothesis testing that they need to calculate, not for you. You don't calculate, you just run. You know run? Run lah, running away from the calculation. Okay, that is the third step. So we recap back. The first one, you need to state your null and alternative hypothesis. The second one, you need to state your alpha or your critical values. So usually we set at 0.05 level of significance. And then the third step is we run the data analysis, either using the statistical software or we can calculate, and after that you need to do a reporting. We need to report the p-value or critical value or significant values, and then we need to report also the statistical value, the t statistic, the f statistic, the z statistic that being produced by the software. And then the fourth step, another 2 more steps to go. Don't worry, ladies and gentlemen. After this finish your miserable of life, you understand these 5 steps, you are able to fly. You are able to fly anywhere in the world. That's correct. Okay. So the fourth step is very simple one. You make a decision. That's all. The fourth step is making decision. But is not punggung, tetapi. But you must remember, your justification of decision must be based on as follows. You got 2 types of decision. The first one are reject. Reject what? Reject your null hypothesis. And then the second one, you fail to reject. You fail to reject your what? Your null hypothesis also. So, how to meet those criteria? I'm going to tell you a song, or I'm going to sing a song for you so that you can remember the formula. Okay, the song are as follows: less than a reject. Okay, if you got your p-value is less than our alpha. For example, after you run the calculation, you observe that our value is 0.03. Our alpha set just now is 0.05, right? So this one is less than or more than? Less than reject. Try to follow. That is the song. Okay. Now that song got the Arabic song first. You need to sing the Arabic song, then you need to translate to English. However, I make it a shortcut. Less than reject. Okay. And then another one is more than. More than is fail to reject. For example, after you calculate or after you run the analysis using the statistical software, you find out that our p-value is equal to 0.06. So 0.06 and our alpha are 0.05. So this one is more than, correct or not? Yeah, so therefore we fail to reject our null hypothesis. More than fail to reject. Okay, after this we sing a song together. Okay, I sing that song once, you sing that song twice. Okay, and then the last one but not least is making decision. It's just a simple way. No, the fourth one is the sorry. The fourth one making decision. The last one is making conclusion. Thank you. Nama dia lain kan, is a different names and terms. So, if you are rejecting your null hypothesis, okay, so listen here. If you are rejecting your null in the fourth step, okay, you got here null kan. Your null is equal to mu1 similarly to mu2. Maksud similarly ni, the mean of the A and B are the same. That is our null. Null apa? Null lah. So another one, we got the hypothesis alternative, which is mu1 is not equal with the mu2. So for example, we run the analysis of the statistic and then we find out that our value are 0.03 and then our alpha is 0.05. Therefore, we reject. We reject our H null. So when we reject our H null, we making a conclusion based on our H alternative. So what is our conclusion then, for example? So we are going to say that there is a difference lah. There is a significant difference in terms of the blood pressure monitoring between A and B, something like that. At the point of significance 0.05, finish. That is the hypothesis testing. Understand? Just simple like that. Okay, unfortunately, sometimes you find out that the level of significance are as follows. You run the statistic and then you find out that the level are 0.06. So 0.06 are more than our alpha, right? And therefore you fail to reject. You want to reject? Oh, fail. Oh, fail. You cannot reject. And therefore your conclusion must be based on your null hypothesis. And therefore you are going to say there is no significant difference between A and B for their blood pressure monitoring at the point of level significance 0.05. That's all for hypothesis testing. When you understand this, you are able to fail. So far so good? So good or not so good is goodest very bad. We have two different types of hypothesis testing. Two different types, different types. So the types that I'm mentioning to you ni is the approach lah. The first one, we want to measure the difference. Difference means that we want to measure, is there any difference or is there any no difference? Means that it's the same lah. Ada perbezaan ke tidak ada perbezaan? Okay, that is the first approach that we want to look into. The second one in the hypothesis testing is we want to know about the correlation. Correlations means that what? Kita nak tahu dia punya perkaitan. Perkaitan or perhubungan or pertalian. Or in other words, we also call it as the association, the influential factors, the influence, okay? So only these two hypotheses that you are going to be exposed with. The first one is to test the difference, and then the second one is to know whether there is correlation or no correlation. So of course, based on this, you already can imagine that the first scope here are going to discuss about H null, mu1 is equal to mu2 as a null. Maknanya ada beza, tak ada beza. It's talking about the differences in terms of the mean. Understand or not? Is there any mean difference or is there any no mean difference? Okay, the next one, same also goes to this. You got the H null. The H null is no relationship and the alternative will be got relationship. That's all. Okay, and then they are utilizing and use the similar approach, the 5 hypothesis testing that I'm mentioning and explaining to you before. The first one, state your null and alternative hypothesis. The second one, state your alpha. And then the third one, run or calculate your values of statistics and report accordingly based on the p-values and also your statistic values. And the fourth one, you making a decision. If your p is less than alpha, you reject null hypothesis. If your p is more than alpha, you fail to reject null hypothesis. And then the fifth step, you are making conclusion based on your 4 steps. If you reject your null hypothesis and therefore you are making a decision, you are making a conclusion based on your alternative. If you fail to reject your null hypothesis, then you are needed to making your conclusion based on your alternative. Okay, so far so good? Or not so good? Or so far I can proceed. So now I'm going to proceed about the hypothesis testing punya analysis data. So hypothesis testing can be divided into two, as I mentioned before this. The first one we call it as the parametric, and then the next one will be the non-parametric. Okay, under the parametric, we got some sort of different approach. This kind of different approach, I'm going to tell you one by one, and I'm going to compare you with the non-parametric. I'm trying to explain this within 5 minutes. Hopefully, you can just focus into this explanation. Okay, the first one, we call it as a one sample t-test. One sample t-test. One sample t-tests are usually being used or utilized or being applied if you want to measure a sample of a mean with standard. You got what I mean? You got something to do with the blood pressure of all of you inside this class. So I'm going to compare it. Remember, this is what about the first one, which is the difference. Difference ni about your comparing with what. So now I'm going to compare with the standard. So I got one population of the blood pressure and I want to compare with the standard. This one we call it as a one sample t-test. Syarat or the requirement under the parametric, data must be normally tabulated. Okay, if your data is not normal, then you are using the second one for the non-parametric test. I can't remember the name. Never mind. After this, we are going to look for it. Okay, the second one is the independent sample t-test. The independent sample t-test can be defined as follows. A measuring of the differences between two independent groups. A measuring of differences between two independent groups. For example, this is group A, this is group B. I got a blood pressure from the group A, I got a blood pressure from a group B. So what I want to do, the first one, I need to run the normality data. Oh, data is normal. I want to compare between A and B. So I'm going to use what? I'm going to use independent sample t-test. So what is my null? A and B having same blood pressure. And then what is our alternative? A and B, different blood pressure. So that is my alternative null and, hypothesis null and hypothesis alternative, independent samples. The next one, we call it as a paired sample. Paired sample are talking about measuring the same respondent, or paired sample also known as dependent sample. For example, I monitor the blood pressure of this group or all of you today. And then I monitor your blood pressure again tomorrow. You will be you tomorrow also, right? For example, you are Muhammad Helmi, tomorrow you Muhammad Helmi also. So that one, we call it as a dependent sample t-test or paired sample, P-A-I-R-D, paired samples. So the paired sample are for us to monitor the same group, the same mean, the same dependent group, but different times lah. Morning, afternoon, today, and next day. That one is the paired samples. Okay, the requirement for the one sample, one group, and then standard. The next one, you got one IV and one DV. DV contohnya macam your blood pressure, your IV contohnya two groups. Syarat dia must be only two groups, A and B. Malay, non-Malay. Gender, male, female. Sekolah, not sekolah. Clever, stupid. Macam tu. Two group only. Example, okay. The next one we call it as ANOVA. ANOVA. ANOVA is for the data. ANOVA, same also like the independent sample. The difference is K more than 2. Example, group A, group B, group C. For example, we got another group C. So if you got another group C, that one we call it as ANOVA. Blood pressure, numeric, kumpulan or groups must be more than 2. More than 2. Cannot 2. 2 independent sample. More than 2? ANOVA. ANOVA stands for analysis of variance. Analysis of variance. Okay, this is all about the differences test. Ujian perbezaan. I'm talking about the differences test first. Okay, if your data is not normal, for the independent sample, is the data normal kan? If your data is not normal, then you need to use the Mann-Whitney U test. Mann-Whitney, I will show you after this. And then if your paired sample t-test ni data normal kan? Data tak normal, you are going to use the Wilcoxon rank sum test. Okay, dah mula tak ingat kan? Okay, the last one, the ANOVA, you are going to use the Kruskal-Wallis test.